Today's lesson is on operations with radical expressions. We're going to learn how to add, subtract, multiply, and divide with radical expressions. We'll start with a quick recap, though, of some facts that we know. So we've learned already that if I have a non-perfect square, such as the square root of 18, I can break that down into an expression of a perfect square, if it has one that's a factor, times another factor. So the square root of 18 is equal to the square root of 9 multiplied by the square root of 2, and the square root of 9 can be simplified to 3 square roots of 2. That was a fact that we've learned already. We also learned back in school that if I multiply a square root by itself, such as the square root of 2 times the square root of 2, I end up with the radicand as the answer. This is the same as if I did the square root of 2 to the second power. Algebraically, that would look something like this. The square root of a multiplied by the square root of a equals a. Or the square root of a to the second power equals a. So those are two facts that we've learned, and those will come in handy when we're doing the operations with radical expressions. So the first operation we'll review is multiplication. I'm going to start with 6 square roots of 35 multiplied by the square root of 5. So in this problem, I don't see any perfect squares. I can't even think of any perfect squares that are factors of 35. So what I'm going to do is I'm going to break down the square root of 35 into a multiplication problem. Multiply by 2 factors. And I notice that 35 has a factor of 5. So I'm going to break it down into 6 times the square root of 5 multiplied by the square root of 7. So there's my square root of 35, just expressed as 5 times 7. And then I have this square root of 5 on the end here. Now this whole problem is multiplication. And when we have multiplication, we can use commutative property. So I'm going to reorder this so that I have all of the, let's call them like terms, together. So 6 multiplied by the square root of 5, multiplied by that second square root of 5, multiplied by the square root of 7. And the reason I've done that is because now I can take advantage of one of the facts that we went over in the recap. The square root of 5 multiplied by the square root of 5 is 5. So that leaves me with 6 times 5 times the square root of 7, which equals 30 square roots of 7. And in my final answer, I don't use any operation symbols. That wouldn't be simplified if I did. So that's how we're going to go about doing multiplication problems. And this works nicely even if there's no perfect square factors of a square root. We'll try one more. We have 3 multiplied by the square root of 22 times the square root of 11. So immediately I see that 22 can be expressed as 11 times 2. So I'm going to do that. There's the square root of 22 expressed as a multiplication of two factors. Multiply by that last square root of 11. And by doing that, I now have two square roots of 11 here. So I'm going to reorder this as 3 times 11, because the square root of 11 multiplied by the square root of 11 is 11, multiplied by the square root of 2, which equals 33 square roots of 2. And that's multiplication. Not too hard. We'll go on to division next. Let's look at something like 9 multiplied by the square root of 28 divided by 3 square roots of 7. Now, to be honest, I prefer it written in fractional form, so I'm going to write it as 9 square roots of 28 over 3 square roots of 7. Right? Both of these expressions are the same thing, just expressed slightly differently. Now, the reason I like it in fractional form is because it lines things up visually for me a little neater. So on the numerator, I can express that as 9 times the square root of 28 over 3 times the square root of 7. And what I like about this is I can see the 9 and the 3. The coefficients there line up perfectly, and 9 divided by 3 is 3. So that'll simplify nicely in a little bit. I'm just going to break up 28 into the square root of 7 multiplied by the square root of 4. And now we can factor this. So 9 divided by 3 is 3. Those will cancel out. So square root of 7 divided by the square root of 7 is 1. And then I'm left with the square root of 4. And that we can simplify to 2. So the answer to this problem is 6. So by breaking the square root of 28 down into a multiplication problem of two factors, where one of the factors has another factor somewhere involved in the problem, I can simplify it out. In this case, it was the 7s. Let's look at addition and subtraction. So we'll take the square root of 16 plus the square root of 9. Well, these are perfect squares, and we know that when we have the square root of 16 plus the square root of 9 and we simplify these down, the square root of 16 is 4, the square root of 9 is 3, and that equals 7. Now, it's really important that you notice, though, that this is the correct answer. This is good. But it's not the same as doing this. 16 plus 9 would give us a square root of 25. That's a perfect square, which simplifies to 5, but look, now we have different answers. So we can't do this. This doesn't work. We have to simplify each one separately first in order to add or subtract. So just keep that in mind as you work through the problems. I'm just going to put here, we can only add or subtract radicands if they are the same. Otherwise, we'd have to hope to simplify them. So for example, let's look at the square root of 12 minus the square root of 3. I can't just do 12 minus 3 on this because the radicands aren't the same. So we're going to do something that we kind of did up in the multiplication and division problems. I'm going to re-express the square root of 12 as the square root of 4 times the square root of 3. Okay. Then we're going to subtract that square root of 3 on the end. Now we can simplify this here. We know what the square root of 4 is. So the square root of 4 times 3 simplifies to 2 square roots of 3. We're going to subtract that square root of 3 on the end. And now look, our radicands are the same. You can almost think of these as objects. I have 2 square roots of 3. I'm taking away 1 square root of 3. I'm left with 1 square root of 3 as my answer. I'll do it with another problem just to finish this off, so you can see this in action again. So we've got the square root of 20 plus 2 square roots of 5. I'm going to re-express this as the square root of 4 multiplied by the square root of 5 plus our 2 square roots of 5. And now I can simplify over here. The square root of 4 is 2. So it's going to leave me with 2 square roots of 5. Bring this down, I've got another 2 square roots of 5. So if I have 2 square roots of 5 plus 2 more square roots of 5, my answer is 4 square roots of 5. And that's how these problems are done. If you have any questions, concerns about this when you're doing it, email me. You can refer back to the video as you work. And as always, use the hints and examples, or use the textbook lesson as you're solving the problems in Math Space today. Good luck.